Right, so we have x exponent 4 minus 16 equals 0. Okay, now this is called a biquadratic equation, or you can also call it a quartic equation. All right, so x exponent 4 is the same as x exponent 2 times 2. 16 is the same as 2 exponent 4. Okay, all right. Now equation becomes x exponent 2 times 2 minus 2 exponent. Now 4 can be written as 2 times 2. All right. Now the next thing we're going to do is the application of the power of a power rule. Okay. So we're going to apply the power of a power rule of indices, which states that a exponent m multiplying the exponent c equals a exponent c m. Now in a situation where the exponents are the same, a exponent m multiplying the exponent m equals, okay, a exponent m times m. Okay, all right, so our equation becomes s squared minus, okay, 2 squared equals 0. All right, so you can see our equation has a form of difference of two squares. So you can apply difference of two squares here. So let's quote the formula. So we say a squared minus b squared should give us a plus b times a minus b. So we are going to apply this to our equation. So we are going to have s squared plus 2 squared times s squared minus 2 squared equals 0. All right. Now let's use the zero product property to simplify the equation. Now it states that if a times b equals 0, then a is 0 or b is 0. Okay, therefore we can say s squared plus 2 squared equals 0. Now let's call this equation 1. Okay, and then we can also say s squared minus 2 squared equals 0. Let's call this equation 2. All right, now let's solve equation 1. Now we say from equation 1, okay, s squared plus 2 squared equals 0. All right, so we want to make x the subject of the equation. So we say s squared equals, so we are transposing 2 squared equals minus 2 squared. All right, so our equation becomes, okay, s squared, okay, x equals plus or minus the square root of minus 2 squared. All right, so you're going to have x equals plus or minus, okay, the square root of 2 squared times minus 1. All right, so from said, the square root of a, okay, times the square root, the square root of a times b can be written as the square root of a times the square root of b. Now let's apply this to our equation. So we're going to have x equals plus or minus the square root of 2 squared times the square root of minus 1. Okay, so this square cancels this root. So we are left with x equals plus or minus 2 times the square root of minus 1. Okay, all right, now we know that, okay, so we say but minus 1 equals I squared. So we are going to substitute here. So where we see minus 1, we write I squared. So our equation becomes x, okay, x equals plus or minus 2 times the square root of I squared. All right, so this exponent cancels this. So we are left with x equals plus or minus 2i. All right, this is a quartic equation. So we are going to name all the solutions that we get, okay? So because we are expecting 4 solutions, we are going to name them one by one. So let's call this Okay, the first solution x1, okay, and then call the second solution x2. All right, so now we are done with two solutions. Let's solve for the other two solutions using equation 2. Okay, so we say from equation 2, so let's reference equation 2. Okay, all right, so from equation 2, s squared minus 2 squared equals 0. Okay, s squared minus 2 squared equals 0. All right, so you're going to have x squared equals 2 squared. Okay, so you're going to have x equals plus or minus the square root of 2 squared. So this cancels this. So we have x equals plus or minus 2. So we say x3 equals 2, and then x4 equals minus 2. Okay, now we can say therefore x1, x2, x3, x4 equals 2i times minus 2i, sorry, not times, comma, minus 2i, comma, and then we have 2, and then we have minus 2. All right,